Good afternoon and welcome to our webinar presentation, Pro Tips for Challenging Wheel Bearing Jobs. We've got 4 great case studies coming at you that cover everything from EVs to pickup trucks. My name is Andrew Markell. I'm the Director of Technical Content at Babcock's Media and the presenter for today's event. Today's webinar is sponsored by BCA Bearings by NTN. No 2 wheel bearing jobs are the same. We'll see that in these 4 examples that we bring in. Subaru, Nissan, Ford, General Motors, to what you have to know to properly service the system and make that bearing replacement go smoother. Okay, I got to introduce Matt and Patrick. Matt Gorski he started in the automotive industry 12 years before he worked in the field and then became a technical trainer, and then he moved into product management. Matt Gorski, he's led the development of NTN's automotive aftermarket product line since 2015. He also brings his work home with him. As the go-to guy for his friends and family, they question about maintaining the vehicle. Matt helps them out, and Matt's experience in the automotive aftermarket and as a technician has made him a great resource. Patrick Cronin, well, he's been in the automotive aftermarket for 7 years and knows the BCA Bearing brand and customers from front to back. He's on those front lines of communicating with technicians and has gained valuable insights to the everyday challenges faced by the technicians when they're installing new wheel hubs and bearings. As an automotive enthusiast, he lives to help people and he brings a valuable point of view to the table. Well, let's get started on this webinar. Let's dive into our first case study, but let's have a poll question first. This comes down to, when do you remove that wheel speed sensor if you're doing a wheel bearing job, working on an axle, or even doing some brake work that may need to do it? When do you do it? First, when you get the car in, is that first thing to come off before the brake caliper and rotor, or do you remove it along with the brake caliper and rotor, or do you wait until the axle nut? If you have any other advice or precautions, please put it in the Ask a Question box and hit that submit button. We'll be looking at those. I'm kind of curious. But Matt, for me, it's always been, if I don't pay attention to it, I'm going to break it no matter what.
First thing I used to do is just make sure, if it's the type that needs to be removed, that it's soaked down with some PB Blaster or your favorite penetrant, and let it sit for a while and take your time getting it loose from the housing so that it doesn't snap off, and then you end up drilling it out and the cost of the repair goes up for the customer. So a little bit of patience and forethought, and it pays dividends.
Yeah, you don't want to damage the sensor or the wiring harness. That's going to add time and expense to a job. So it's definitely best to take care. Know the application you're working on before you start taking parts off.
I remember the early ones, the problems with General Motors wheel speed sensors and that bolt that would never come out. It was a Torx or an Allen, and this took forever. But that's great. Okay, so we have 11 people say it's the first item they removed, 50%. 40%, they say when the caliper and rotor has been removed. And only 2 people said, 9% said that they remove it when the axle nut's removed. So it's, take caution. Yeah. No sense in damaging a wheel speed sensor because they're tough to find sometimes. But let's get started with our first victim or case study. It's a 2015 Nissan Altima. Customer states that they had the wheel bearing replaced recently, and now there's a noise and the ABS light is on now. Went for a test drive, the ABS light's on. We pulled the codes. It was a C0040 for wheel speed sensor circuit malfunction, right front, and C0223 for right front wheel speed sensor erratic. So what's going on here? Well, if you were to go back in time and look at what was going on, when they replaced the initial bearing, you'll notice that there is a bore in the knuckle that the speed sensor comes out. And there's also on the outside, we see that pad where the bolt goes down and holds it into the knuckle. But if you've had a Nissan wheel bearing job recently, you're going to kind of recognize something that probably shouldn't be there or is stuck in there. It is that ring with the 3 holes in it that's in the center of the bore. That is actually part of the wheel hub unit that was originally on the vehicle. And if you look at the replacement bearing, you'll see that same cap. Well, what happens sometimes is the bearing's not clocked in there properly, or the old one's left in there. And when the new one is inserted, it damages that wheel speed sensor. Even if you took it out, you may, if you have that technician who doesn't have the feel for what's going on, you put it in the bore, tighten it down, and all of a sudden it's hitting that little plate there and it's damaging the sensor, which can cause it to crack, which changes the resistance. And that's where you get that circuit code. It could be open or shorted. Or in some cases, you could get an erratic speed sensor signal because you're changing that relationship from the encoder ring, which is on the back of the bearing, to the sensor itself, and that could cause that erratic codes, because erratic codes are essentially, it's looking at the other three wheel speed sensors and sort of figuring out, okay, this guy's being a goofball over here by having, showing 7 miles an hour and the rest of them are showing 12. But yeah, the second you tighten down on that bolt, it damages the sensor. So best advice, make sure you're looking at the bore itself to make sure that that ring is removed. Clean it up inside. Some emery cloth, Scotch-Brite pad to make sure that rust is, and then the bearing can go in there a little bit easier. So we replaced the wheel bearing on this, and everything was great. Patrick and Matt had this great tip going through the TSBs for this one in particular. Is Nissan, Toyota, BMW, and I think even Audi have a TSB out there, a technical service bulletin, that covers a certain thing that may sound like to your customers a wheel bearing noise, but what it is, it's a clicking noise as the vehicle brakes and then also accelerates. And what they found where the noise is coming from, it's not the subframe, it's not issues with suspension bushings or motor mounts. It's actually that interface between the shoulders on the CV joint axle and the inner bearing race. So included in the resource center is this Nissan TSB, and I think there's also one for Toyota in there too.
Yeah, and Andrew, this is a super common problem with these Nissan wheel bearings. You want to make sure before you start, like we said, before you start taking the hub off the vehicle, you want to make sure you know how the wheel speed sensor is attached. If it's integrated into the wheel hub, you have to be careful for the wiring harness. If it's separate from the wheel hub, you have to be careful with that sensor. That little nub of the sensor you showed can get damaged. Now you're replacing part of the harness, and some of those wheel speed sensor harnesses, you got to chase way up into the vehicle, so you might have to take the fender liner off, or who even knows?
Chase it up under the hood and into the trunk.
So that can make a quick wheel bearing job into a bit of a nightmare, and if you have a customer sitting in the waiting room, that's not a conversation.
Yeah, why is my trunk and hood open?
Yep. Why are you taking my entire front end apart? Why are you taking my fender off? Well,
But the use of the paste or the glue or bonding agent, whatever you want to call it, to help close that gap and eliminate that clicking noise is pretty common throughout. So understand in the initial diagnosis, what is the noise? Is it a grumbling, a grinding, or is it a clicking? Nowadays with TSBs, it's pretty quick. Just enter year, make, model, VIN code, or even plate, and it'll tell you if there's any TSBs tied to the driveline on that. So.
And this example we're looking at here on the screen right now, we thought we'd include because this one's a little interesting. Like Andrew said, it's a common complaint, a clicking or cracking noise. They think it might be related to a wheel bearing failure. And it's actually, microscopic movements. The axle spline and the splined hub fit real tight, as does the hub and the knuckle bore. But there can be microscopic movements which will cause that little clicking sound. So what they will recommend a grease or a locking fluid that kind of fills those little spaces and really locks it in a little bit tighter. Usually a pretty easy fix. Sometimes you don't even have to take the hub off. You can just back the axle off or whatever from the inside of the vehicle.
A little brush applied in.
Yeah. But this TSB we're looking at here is for a few late model Audis. And and it's a quick fix, but then it requires an 8-hour cure time before the vehicle can be moved. So if you have a customer in and you tell them, well, this is a quick fix, but then, by the way, we're going to have your car overnight because it needs 8 hours to cure. So before you quote the time on a job or before you have a customer waiting for their vehicle to be ready, make sure you pay attention if there's a cure time or a drying time to add that to the job.
Too bad you can't book those 8 hours.
Yeah, I don't. You cannot bill them for those 8 hours. I don't believe the technicians. Maybe we should have a poll question for that. But I think you guys know the answer to that.
But in general, look for these TSBs, and I know that there's probably some technician out there thinking, well, maybe every wheel bearing job that's front wheel drive, there's an axle going through it, I'm going to put a layer of moly coat on that area. Doesn't really apply to all vehicles.
No, and like I said, I would go with the manufacturer's recommendation, just to cover yourself.
And make sure that you don't get any of that sealant on the threads for the axle, because that could totally throw off the torque on it.
Especially after 8 hours.
So let's move on to our next case study. We got a good pace going here. We're 15 minutes in, and we got that first case study. So let's go move on to our next one, which is the Ford F-150 IWE wheel bearing. Let's do a poll question on this. This is probably one of the more common wheel bearing jobs out there. What IWE failures have you seen at your shop recently? Has it been the bearing failure? Has it been the damaged IWE actuator, the vacuum part of it? Is it the solenoids underneath the hood? Or is it just your generic vacuum leak? These ones are starting to build up that age to where the hose starts to crack at the actuator and the wheel and vacuum leak. So kind of give us a feel for what you're seeing out there in your experience with these IWE bearings.
And to be clear, this is the F-150 platform, the newer ones with the vacuum-assisted four-wheel drive hub engagement.
And that integrated wheel end is a nice bit of engineering. It done in the interest of efficiency, fuel economy, but it does add some extra twists and turns to diagnosing noises, and it does add a couple extra points of failure. So we know the F-150 has been the best-selling pickup truck, for many years. So there are a ton of these out there. So you're gonna, if you haven't seen many, you probably will.
We sell quite a bit of them, and we just want to make sure that when you're getting a diagnosis done on it, you just don't automatically blame the wheel hub assembly, because there's a couple things that attaches to that can cause this problem.
And this is great in our survey here. Bearing failure, that's the leading cause, what they're seeing at the shops. Damage to the actuator, that's only 35% of the time. IWE solenoid failures, that's the one. I know the early ones, like 12 or 13, they had that solenoid and relay, basically underneath the windshield, and it would get flooded. So that's common. And then vacuum leaks, that's coming in second place. But with this vehicle, the customer originally came in with the right front wheel is making a ratcheting noise, and with two-wheel drive engaged. And then it changes when it goes into four-wheel drive, but there's still sort of a grinding noise over there. So we actually have some audio clips that Patrick found, I think, of what this sounds like.
Yeah, Andrew, I'm going to play 3 audio clips for the folks in the audience. The first 2 are turning the hub by hand, so you can get a feel for if you're under the vehicle, what it's going to sound like. And then we've got one driving the vehicle, so if you're on a road test, you can kind of identify that. But this first one is slowly turning the hub by hand. Now that noise could be, it sounds like a metal rattling. Maybe it's the backing plate, or maybe it's a skid plate or something that's come loose. I'm going to play it again. A faster rotation. A little harder to make out, but it sounds like more than just a piece of tin rattling around.
And if you've ever had one of these, and I have had several, it just sounds like a ratchet, like you're spinning a ratchet, like a fidget spinner, and it just sounds like a ratcheting noise because it's the partial engagement of the engagement gears.
And then this final clip we're going to play is driving. So now it's more of a higher pitch sound. It's not as much of a ratcheting, but you can still hear it. So that just sounds like something is not rolling properly, or something under that in that wheel is not working right. So a lot of people think, well, it's the bearing.
It could be the actuator. Yeah.
Yeah. After a few of these that you've done, you'll know that sound right away, and you'll have three things in mind. It could be the actuator, it could be the solenoid relay, and it could be a vacuum hose. So, but rarely is it the fault for that noise for it to be the hub assembly, because that isn't, there is no moving parts on the hub assembly with vacuum applied or not. So, and here's a good illustration of that.
It's kind of interesting how this system operates with the vacuum pressure, because in two-wheel drive, vacuum is being applied to the unit itself, and it pulls that ring back so it's free to rotate. But in four-wheel drive, and this is sort of like the fail-safe mode with this, they turn off the vacuum. So the ring gets against that spring and engages everything together. It's sort of a fail-safe because they don't want to leave someone stuck in a mudslide with a two-wheel drive because of the vacuum issue. So it sort of cancels it out that way. But another thing you can kind of pick up on these trucks sometimes is the IWE will it disconnects both at the front differential and at the flange itself. So, and the wheel bearing hub unit. So essentially that axle in the center there is freewheeling, and that's what kind of creates the efficiency with it. But, to rule out the vacuum side of it, it's critical because a lot of these units could have issues with, number one, the vacuum lines going to it, the solenoid that shuts off vacuum pressure to it all, and as we saw in our survey, the decay issue, because vacuum can decay going to these, and essentially the decay is caused by a leak, and you'll get the same noise. And
Chrysler had these back in the Jeeps where they had the vacuum actuator to move a clutch fork-ish thing to slide that gear back and forth over this thing. So instead of doing it by the pumpkin, they're doing it out at the wheel end now.
And when you hear that ratcheting noise caused by the partial engagement, we get the question, do I need to just change the actuator? Do I need to change the wheel hub? Do I need to change both? And the question becomes, that ratcheting noise can damage both the actuator and the wheel hub. So depending on how much damage is done before the issue is found, it could necessitate replacement of both. Sometimes you might be able to get away with just replacing the actuator if the wheel hub, the gear on the wheel hub isn't too chewed up. But if you replace one and not the other, and they're both damaged, you might get a comeback. Yeah. And then, we talk about comebacks a lot, and we know a comeback can cost a shop, $800,000, $500 or more at least. Plus these wheel hubs are pricey. So if you put on if you damage the new wheel hub, then you have to replace it. You're in over $1,000 on this comeback. Yeah. Not to mention an angry customer. So
best practice would be to make sure all mating surfaces and gear engagements are new. So.
Yep.
And the thing to realize, the actuator, the cog in there, the ring that goes over the two, that's essentially a sacrificial part. It's a little bit softer than the metal on the hub unit or the axle, and that can get chewed up pretty quick. And they're not that expensive to replace the actuator.
For the part, you still got to tear it all apart to get to it.
Oh yeah, and that's the worst part of it. It always seems like when I work on these, most of the damage I cause is when I'm removing the hub unit, and I'm so paranoid of damaging that IWE actuator. And this is sort of like the neat thing about this bearing is it has 4 bearings instead of the typical 2. So you have 2 taper roller bearings that support the weight of the vehicle. And then inside you have a ball bearing, and then these are more or less needle roller bearings on the inboard side of it that support that axle and allow it to turn freely when it's in two-wheel drive. And all four of those bearings inside of it can go bad. There's seals involved with that. So it's a pretty complex bearing. And on top of that, how they set the preload, it's pretty interesting. Patrick, Matt, what exactly is orbital forming? And how do they use that to keep that cog on there?
So orbital forming is just the deformation of the steel inner ring. So you're kind of peening it over, if you will, or rolling it over onto itself to lock the inner ring to the outer ring. So, the wheel flange, I'll say, that's the part that gets rolled over the bearing housing. And that's what's going to keep the preload, and in this case, they sandwiched the drive gear, the IWE engagement gear, between the bearing housing and the inner ring portion. So that's also important because that cannot spin, or it will just spin on that housing. So it has to be clamped on at such a force that it is not going to break free and spin, and it will actually turn the wheel, whether you've got factory wheels or 35s on, you're stuck in a rut, or pulling your boat out of the boat ramp. So it's critical to have that rolling over and preload set precisely, and we've got the machines that do it. Then afterwards it's x-rayed and inspected to make sure there's no cracks or failures. So it is a fairly detailed thing, and it just adds to it when you have to capture that gear in there on these IWEs.
And you don't want to have a breakdown at the boat ramp, because someone will film it and put it on the internet. You will go viral. People will be laughing at you.
They didn't use OE quality hubs.
Yeah, look at them. And another thing with this design that you see here in the diagram, because it's a rolled closure and the preload on the bearing is set at the factory, there's still an axle nut. Mm-hmm. And that axle nut basically serves just to properly retain the axle. And you want to make sure you know what the torque spec on that is. I believe the axle nut on one of these hubs is like a 30 foot-pound real.
Yeah. On these Ford F-150s, you laugh because it's like a little 10-millimeter nut,
tiny little,
and it's just a retention thing because all the load is being carried through, the other bearings. It isn't a typical, a hole with splines like 99.9% of the other driven hubs are. So it's a different design, which doesn't require the preload on that nut as much as it does on the rolled closure end of it.
Yep. So check the torque specs. Why one ugga might be too much for that little
10-millimeter nut. Yeah.
Hey, we just had a question come in regards to the ball bearings and on the outboard side of it in the bore and the needle roller bearings. If those fail, do they make any unique noises that we should be aware of?
Well, in my experience, I've never really seen any of those go bad. They don't see a lot of load at all. They're more high speed, and they're not prone to failure. So to be honest with you, I've never seen one. I've never had a labor claim or a warranty be processed for it. And we do not, nor does anyone else, seem to offer those components separate. So again, it's just more of a supporting role for the spindle portion of it. But I just look, they're sealed, so if you see any grease coming out of them, and just a visual inspection, but doing a typical shakedown of the thing, I don't think you're going to see any movement out of those. But
and if those do fail, they're gonna generate some heat. Mm-hmm. But as far as noise, I haven't heard of anything either that diagnostic noise you might hear. Mm-hmm. That's a good question.
To our audience, keep those questions coming in, and we'll answer them at the last part of the event here. So, you mentioned before it's a couple hours to get this, in and out. It's not really that bad of a job to do, except, making sure you have the correct torque specifications and everything else. Matt, Patrick, can you also give an idea, like you mentioned before, a low quality unit versus a high quality unit? What should they be looking for in these?
On the IWE specifically?
Yeah.
The main thing I'd be taking a look at is the condition of the gears. So a lot of them I've seen that were lower quality aren't as rounded. There is a profile to them so that engagement ring will slide cleanly and tightly onto the drive gear. Sometimes I've seen some where either they're too loose or too tight to where the vacuum is being removed, but that gear will not slide and engage with the teeth on the hub assembly because it just has burrs. It's not as clean. So it has to be precision because it is a precision fit, sort of like a manual transmission, gear engagement with a synchro. But that I've seen a lot of problems with. I've seen problems with the ABS wires, but specifically the rolled closure, because I have seen cases where they will engage the four-wheel drive and it will engage, but then you can't really see it because it's hidden behind the knuckle, is that ring that is pressed onto that inner ring to drive that inner ring and turn the wheels is spinning on the shaft. So they didn't get the preload correct on there. So it was, installed, pressed down, but not enough to bind it to the inner ring to turn the wheels. So I've seen, 2 cases of that. One in person and one in the forums, but so there's cases of that, but it's, I've seen cases where the rolled closure over the ring has cracked. They don't do the x-ray after the process. They don't get the pressures right. Just some of the those are the critical things that I could speak to.
And the easy answer for me, Andrew, is, with these hubs, there's a lot going on, multiple different types of bearings, the engagement gear, the wheel speed sensor. Don't cut corners on an application like this.
Especially if
go with an OE quality brand like BCA. I like to say so.
Especially if these are on fleets, you got to plow on it, or you're towing your camper. Like I said, your boat out of the boat ramp, you need 4-wheel drive. So usually people who have the F-150s, they're working trucks. So if you really want to, save, $30-40 and hope that it works, or get a good quality OEM part and know that it's going to work when you turn that button, push that button.
I know we talked about this before, but one of the signs for me that it's a low quality unit is the ABS wheel speed harness. It's sometimes never the right length. It's too long. It might be too short. The connector may not be the same. With this vehicle being, so many of them made, is there any difference between, let's say, like a 13 to, let's say, a 21 or 22 right now?
Yeah. In fact, we've got a couple. If you take a look at some of the year ranges of these things, the hub itself may stay the same, but the length and the locations of the mounting areas of some of the harnesses change. So, and then some people will say, well, if I just change the sensor and, can I swap out the hub with this? So there's people that ask that all the time, but to be safe and to be sure, we have separate year ranges. We don't do any consolidations because this one's only 3 millimeters longer, and you might not be able to, get it attached properly on the upper control arm, but you can zip tie it. So I've seen all sorts of shady stuff done with some of these ABS sensor wires because they are all very similar, but they're different depending on if you've got the Raptor, if you've got a certain engine or a certain ride package. So they're pretty specific, and they're I've seen some where the weather pack connector that connects to the OE housing doesn't have the proper sealing O-rings, so you're going to get water intrusion into there, especially if you're on a boat ramp or you're out four-wheeling, and then you just get all sorts of ABS codes eventually. So they don't have the wear reducers, those little corrugated sleeves on there to protect that rub point. So yeah, it's a place, a lot of places, a lot of suppliers will cut corners to save money, and that we don't agree with.
And you brought up another thing that's probably going to be in the box. Patrick was talking in regards to the torque specifications for that center bolt being, 30 foot-pounds. These torque specifications, everybody's seen on the Ford stuff, that little garbage can icon next to a bolt, might be torque to yield. That might be Ford's way of telling us that maybe we should pay attention. But knowing those torque specifications is so critical. And you guys have a new way to sort of give that technician a tool in the bay to use.
We do, Andrew. And we can't stress this enough. follow the torque specs. Those exist for a reason. Someone way smarter than I am came up with those, and a lot of you may know. For years, we at BCA have included a torque spec booklet in a lot of our hubs that require a torque spec. The issue with these is they're outdated almost before we can get them printed and in the box. So what we've done is we have replaced the torque spec booklet with a QR code that you will find inside the box. Scan the QR code, it'll take you to our torque spec lookup app, which you can see some screenshots here on the screen right now. You look up any vehicle that's in our catalog for North America. So it's, thousands of applications included in there, tens of thousands. You will get torque specs for the axle nut. You will get torque specs for the hub mounting bolts. Mm-hmm. You will get all the notes if you need to back it, if there's a back off, or if there's, so that's all in there, and it's all up to date. If it's a 2023 vehicle that just came out and you got it in the shop, that's not going to be in the booklet because that was printed 2 years ago. Check out the app. It's all up to date with the latest information. So that's in the box with your BCA wheel hub. And all the shop owners out there, see your tech on the phone, make sure he's not looking up a torque spec app before you start busting his chops.
And this brings up another one that you brought up. Another bonus tip here. A lot of hubs are using, I've heard it called flange mount. I don't know if there's a different name for it.
Flush mount, flange mount. So they're going away from the internally splined holes. Now these are mostly European applications right now, but instead of having a hole with splines in it, they've moved the splines to the outside, and the mating splines are going to be on the outboard of the outboard CV joint, and it will engage at that point. So something just different, something similarly tied to the IWE. So instead of having a ring on the outside, these have just moved them to the flush facing the CVJ.
And that's going to change the design of the axle, obviously. It's going to change the location of the magnetic encoder for the wheel speed sensor. So when you do run into some applications like this, some things are going to be a little different. And of course, the torque spec is going to be critical on these as well, because you're literally pushing those two surfaces or pulling those two surfaces together. So the IWE is not the only wheel end that's got a unique spline design. So keep an eye out for these.
Yeah, and my gut tells me they might be doing this to get away from some of those TSBs with the pace, because there is an inherent issue with that design. So maybe this is going to be a better way to eliminate those issues moving forward.
And the important thing with this is the torque. It's usually a torque to yield bolt, at least on some of the Volkswagen and Audi stuff, that has to be replaced every time. And it's a pretty good 200 foot-pounds or more of torque required for that bolt.
Yep, with a big old Torx head on there that's always fun to work with.
So let's move on to our next case study. And this one is everybody's sweetheart out there, the Subaru wheel bearing in the rear due to corrosion. This is the hub unit, not the cartridge style wheel bearing, but this is the one that just, it gets everybody at one time or another. And here we have another poll question in regards to this. What's your go-to method for these rear wheel bearings? Is it air hammer, torch, special tools, sledgehammer, chemicals? Select which ones.
Dynamite. Andrew, we all know the all-wheel drive Subarus are super popular, especially in places that have snow in the winter
and salt and sand.
So they coexist with the toughest conditions for a wheel bearing to live in. So everyone's got a different method to break the hubs loose, but the corrosion on these is a real issue.
You just do a quick YouTube video search, and everyone and their brother's got a different plan. Some work, some don't. Some are dangerous, some are benign. But it's interesting. It's certainly like the whole 10 millimeter socket meme all to itself.
And it looks like here we have special tools for the win. 55% of people saying that they use special tools, which I fully endorse. I mean, there's some really neat stuff out there for removing wheel bearings that I would never have thought of. Some of these are pretty ingenious. I got a slide on it coming up here.
I bet 80% of those people have tried the other procedures and said, you know what, I'm just going to go to the tool that works instead of trying to save money.
You know, the funny thing of it is Subaru really doesn't have a special tool for this. They do show a slide hammer now and then in some of the service information, but I ran across this for, I want to say it was a 2017 Legacy. Yeah, showing a guy taking it off with one hand, I don't think that that's ever going to happen, and that's in the service information. And we all know that it never really pans out that way to where you're able to remove that axle nut, push the axle nut back out of the splines, it comes off. I mean, I would question if there was a glitch in the matrix if that happened to me. But you know, what we see sometimes is pretty bad. I mean, to dent that casting for the hub unit and the body of it, that takes a lot of force. I'm really scared of that guy with the sledgehammer who did manage to do that. The other one, it looks like this guy actually tried the bolt method of having it up against the knuckle itself and pushing it out. Managed to tear up that flange pretty well. I'm surprised he didn't manage to rip it out of the body itself. And then, you know, that general carnage that we see, you know, you take off the rear wheel on some of these Subarus, and you see some of the carnage that happened before to replace that wheel bearing. It's not very nice to look at. So a lot of people ask, what's the problem? Did Subaru weld it in there? Did Subaru do something with the metallurgy? There's all these conspiracy theories. You know, it's up there with the EJ 2.5 liter flat 4 engine and the head gaskets. This is, yeah, you're right. It's almost a meme on its own. And the problem comes in is how far that bore from the unit goes into the hub itself, the tolerance there, and the heat that can basically cause that corrosion to happen a lot faster because you've got brakes right there. It's hot, cold, and that usually gets the corrosion going pretty good. But in my opinion, what makes this such a difficult wheel bearing is, you know, you look at some of the General Motors stuff, you look at some of the Ford stuff, and they have lands that the puller can, you know, latch onto and then pull that out. Subaru, it's very difficult.
Well, yeah, in this case, a rolled closure design where the wheel flange and the bearing housing are kind of mechanically fused together. It's easier to grab onto that wheel flange and pull it out without it just pulling free from the housing, and then you still got the housing there and the ball bearings are exposed. So yeah, they use open design, not rolled closure at the OE level. So if they'd done that, it might help in removing this so you're not taking it apart in multiple pieces. But you know, we got a pretty good relationship with Subaru, and we've had some discussions and suggestions what they could do to maybe, you know, create the bore and the knuckle that receives the hub a little bit bigger, or put some sort of coating on there at the factory to reduce galvanic corrosion and stuff. And, you know, they have to know about this problem, but what they're doing about it, I don't know. But it is frustrating at every level.
In the meantime, though, we've got good suggestions for at least.
Some tried and some true.
Oh, here's one now.
This is one of the most common ones where people just cut off and pound out a wheel stud and use a grade 8 bolt and try and drive it against the backing plate or the knuckle with the backing plate between, but you're going to dimple and tear possibly, and it can cause some damage. But this is for the do-it-yourselfer that's in the driveway and can just go to Home Depot and get a bolt and a nut to make it happen and not invest a lot of money in special pullers or tools.
And you should know if you're doing this, it's, you know, you're kind of prying it out there a little bit, which can cause more trouble, make it more difficult. You know, you're not pulling it straight out, but even if you can get it to pop loose this way, you're going to be better off.
If you can get it to move a fraction, I mean, movement is life, and if you can get it opened up a hair just to get some PB blaster between there, and you work it back and forth 1,000 times, it'll come loose. But the key is getting it to just move.
And we know, you know, a lot of technicians like to try this first before they get out before they go to the next extreme.
Well, and this works very well on most other brands, but with Subaru, I think this is just the rookie do-it-yourselfer. First time at it, you're going to give it a shot, but then you usually, in frustration, give up and then go rent a tool.
We got some great comments on this one from Harley. He said, one-hand removal if you're Hulk or Iron Man. Thank you. And Ali had a great comment here. On Subaru, I use the Wrath of Zeus himself. Hammer, torch, air hammer, pure rage. I'm with you there.
Rage is the key component there.
That's where, if you don't want to have windows into the waiting room when you get to that point.
Soundproof, put them in the back bay when you know you're doing a Subaru hub.
My method, you know, and this was number 2 according to our survey, the good old air hammer. I just bought a brand new one. I think it's an AirCat. Awesome. I mean, I can do anything with that. But the air hammer technique I like to do is I like to try to rotate that hub unit in the bore by hitting on one of the eyelets for the bolt. I've had one break on me, but you know, it seems like a pretty solid technique. Trying to use a air hammer to kind of wedge in between the knuckle and the hub, it never works. Nope. One other thing that I saw is can use this on the Legacies. It's kind of tough. You got to have the right air hammer socket bit. Is hitting the back of the bolts that secure the hub unit to the knuckle. This can help to pop it out, especially if you got a really good air hammer, and it makes it works most of the time for me, at least.
Yeah. So, you know, that's one of my favorite ones, and the nice thing we have is we have the dimensions of the knuckle bolt threads on the back, so the flange diameter. On the flange specs, we show it's an M14 by 1.5. So you can go get a bolt, so you're not beating up on the OE bolts that hold it. So you take those out, you run some sacrificial bolts in there, and you just wail on those on the backside, and it'll drive it through that knuckle. And that's my favorite way of getting stuck hubs out. Is sometimes just, you know what, I'm going to take the knuckle off, and or swing it out of the way if I have to, and just get behind it with either a good powerful air hammer and the proper tool, or just a 5-pound sledge and beat on it. Have someone that trusts you hold a socket on there while you hit it. And again, you just need to get that thing to move or break free just a little bit, and then you might be able to go on the outside and use the rotational technique that Andrew was talking about. Sometimes it's a team effort.
Oh, yeah. And speaking of the team effort, there's a lot of special tools out there that technicians can use. I just bought one myself of I don't know what you exactly call it. I call it a hub unit removal tool, but it bolts onto the hub unit or flange, and then you just start wailing away with the sledgehammer. It's worked. You know, there's others more complex ones like the tool from ProMax, which works well because it basically creates that area for a press on the knuckle to help you to pull it out. And then, you know what? I've had luck with some pullers. I'm trying to remember exactly what out of the OTC catalog of what that is. But you know, I've been lucky enough to get that to work now and then. But it's not much fun.
No, but there are special tools out there, and like Matt said, if you can get it to move a little bit, then you can bring in the chemicals and make it a little easier. Sometimes it's, you know, a combination of solutions is the easiest way to go. So.
Mechanical advantage.
You know, and some of these penetrants, they do work to help break up the corrosion. Give them time to work. Sometimes heat can make them work faster. The hub unit itself on these, is there anything unique about the Subaru hub unit?
We've looked at it and we've done measurements. We've seen if other bearing manufacturers have reduced the OD where it goes in, and that's a critical dimension that's set by the factory, so everyone stays with that. So there's really nothing unique because these are the same types of materials and dimensions that go in Nissans and Toyotas and everything else. My personal belief is the engineer that designed the knuckle and the engineer that designed the hub didn't talk. And I think that the tolerance between the hole and the OD of the bearing aren't forgiving enough. And like we said, when salt water and sludge and dirt gets in there, it just mixes like concrete. And I think that's what it is. And there's not a lot of room to for it to move and break free and loosen up. And I think that's the death knell of this thing, is I think just such tight tolerances between the bore of the knuckle. And I know some people that will sit there with a little emery wheel and just try and open it up a little bit more once they get it out. So the next time it happens, you got a little bit more wiggle room.
Cool. Hey, just a reminder to our audience, keep those questions coming in. We're going to address those at the last part of the event. We just have one more case study, and this is going to be a short one before we move on to the Q&A portion of the event. We're seeing a lot more of them on the roads. They're not too much different than a normal internal combustion once you start getting into the wheel end, brakes, suspension. There's not really that much of a difference. But the big difference is typically there's no internal combustion engine to drown out tire noise, wheel bearing noise. And some of these are completely normal. With these, it's pretty typical that, the NVH situation on these vehicles is way different. It's, for example, I was working on a Chevy Volt yesterday, and I was pulling out the window regulator, which is our wonderful General Motors parts from the Cruise. But what made it different from the Cruise was the level of soundproofing in this door. So you had the door panel, then you had another 2 barriers underneath it to block out sound. And a lot of these vehicles, you're going to hear a lot more tire noise, wheel bearing noise. And what these automakers have got done is they've gone to defining these noises and saying what's normal, what's abnormal, or basically what we're going to pay warranty for and what we're not going to pay warranty for. But this link here in this presentation that links to the Tesla website, this is the owner's manual for the Model 3, and it has different MP3 recordings, which I think is kind of neat for what's normal and what's abnormal on the vehicle. General Motors has done this. If you see a lot more of these TSBs, they're going to have links to videos and also audio files in them. Click on those. They can be a huge help. But as we said before, no engine, no noise. How do you prevent that customer from hearing a tire noise, a wheel bearing noise, that cyclical thing that changes with vehicle speed? Kind of interesting. A lot more automakers are using active noise cancellation in the cabin of the vehicle. And what this is, it is the audio system in the vehicle producing a tone or frequency that cancels out an undesirable tone or frequency. So it's looking at vehicle speed. It even has a microphone inside listening for this stuff. And it will send out a frequency to cancel to keep it even quieter inside the cabin. Tire noise and wheel bearing noise, according to the engineers, is probably the easiest thing to kind of fix. But maybe a wheel bearing. So make sure you're doing your inspection on it. Also, other things on the vehicle that can cause a lot of noise that may kind of simulate a wheel bearing noise or that clicking or ratcheting noise sometimes, and this is addressed in some of the Tesla stuff, is the ABS HCU, because it's being used more than just for ABS braking incidents. It's using for other corrections. It's even making noise when it's doing a brake bias modification when the car's coming to a stop. So that's a leading cause of noise. Nissan Leaf, it actually does have a lot of issues with the electric hydraulic power steering, which is basically a motor that activates when it's at certain speeds to make sure that the vehicle's running properly. But noise is a big issue. And here was one wheel bearing thing that I got involved with, and it wound up being something completely not what I expected. Bearings were fine. And on this unit, it uses a couple different styles. These are hub units on this vehicle. But you're going to love this. With that ACM, there was actually a update to the infotainment system for the software for that system. So with this infotainment system, what it would do is also run the active noise cancellation. And the OEM, General Motors, was actually updating that software to address a tire and wheel bearing noise issue. So it was updating that software, making sure it could correct for these. And what happened, that solved the problem. But another thing to look for on these vehicles is to make sure that the microphones aren't blocked inside the vehicle, because if you block the microphone, it's going to assume something else is going on, and it may not properly adjust for the noise inside the vehicle. So yeah, you could be reflashing for a wheel bearing problem.
That was GM that was able to back service a noise canceling program?
That was off the record. I had to kind of like, but it doesn't, it announces that
they program it for some people I go on road trips on.
Yeah. Unfortunately, I don't think there's no over-the-air updates for a bad wheel bearing, unfortunately.
But, you know, that's what we're going to come up against. What's normal, what's not normal, defining what's normal, doing the diagnosis, and then maybe even checking for updates in the infotainment system. So that's sort of the future that we see going on.
And one I thought was real interesting, Andrew, was the Teslas can make a clicking noise. And this is in the manual, but it's actually because the contactors physically open to cut off the battery from the vehicle. So you might hear a clicking noise and think it's, you know, what it is, that the axle shaft is interacting with the hub unit or something else, because we do hear a lot of clicking noises, you know, reported for wheel bearings. But that's just a feature that you'll find because it's an electric vehicle. So start by you know, canceling or crossing those off the list before you start tearing the wheel end apart.
So that's what we got for the live presentation on this. I know we're going to roll into our Q&A here in just a second. Good question here. Do you recommend an alignment after replacing the wheel bearings, especially when heating or beating it out? That's an interesting take on it. I've heard statistics that, you know, if wheel is out of alignment, that causes a change in the load path for the bearing. Is that recommended?
Me personally, I've never done it, never heard of it, where you're replacing a part that isn't, when the replacement or the wear isn't affecting the components that are adjusted to get that the wheels in alignment. So replacing that part to the factory spec should bring it back into the factory spec for the alignment. It's sort of like, you know, if you had a bent rim, you know, replacing that, do you need to then do an alignment? The answer is probably no. But if you're pounding on it so much that you think you might have loosened up a ball joint or bent a control arm, you know, maybe, but I don't think that the two are linked.
And like Matt said, if you're beating on it enough that you feel like you threw the alignment off, you should have stopped and tried a different solution.
Sliding off the lift.
Yeah.
I mean, no, the amount of force it would take to knock a car out of alignment, I think it isn't warranted for, you know, we get that call quite a bit in emails about, you know, if a warped rotor, can that cause, you know, premature wear in a hub assembly? Yeah, it can, but then is that going to affect the alignment? No, it's not. And so we get that tire alignment question quite often, is how are they interlinked and what should be done that would require an alignment and what doesn't. So in this case, I would say no.
Glenn had more of a comment rather than a question here. He says, can you discuss the importance of properly torquing the axle nut? Many techs still use their impact wrenches to tighten the axle nut. I'll let you guys have that one.
So, yeah, so here's what I'll say. It is true that having the rolled closure that we discussed earlier, how they peen over that inner ring to the bearing module, that does set the factory preload, and that has reduced warranties and failures a whole lot. So the reason, before that procedure, there was two reasons for wheel or axle nut torque spec. One was setting the preload of the bearing, which is now being done by the rolled closure design, but also ensuring that the splines of the driven axle shaft to the mating splines of the inner ring are set and fully engaged, because if that's loose, it's going to cause vibration, noise, premature wear, could cause some vibration, it could cause all sorts of problems. So if it's a rolled closure, it's imperative to have that axle nut torqued properly for the engagement of the driven splines on the axle shaft to the inner ring. So, you know, it still is important, and over tightening is just as not good as under torque. So,
and most people don't know how to recognize if it's an orbitally formed or rolled closure. And there are a lot of vehicles out there where the axle nut still sets the preload on the bearing.
yes.
And
Like
that
Super.
changes
Mhm.
where the balls roll on the race.
Yep.
So if it's too tight, you know, the balls might be off center. That's going to lead to a premature failure every time. It might go 10,000 miles,
Yep.
or more or less, but you don't want to have a comeback for something that's so easily avoidable. You got the torque specs, you got a torque wrench, combine those and do it right the first time.
Got another question. We only have time for about one more question before we've reached the top of the hour here. So this is our last question we'll have, but as a reminder, we'll answer your questions. If we didn't get to it, we'll send you an email here. This is interesting from Dave. Do electrical grounds affect the bearings, i.e. Aftermarket sound system, corroded, broken, bad ground straps? Are bearings electrified? I guess that's the question.
They can be, especially on some of the new electric vehicles. There are cases where they're being they're finding the easiest path to ground, and sometimes that is through the vehicle chassis frame, everything. The only thing between, you know, like the ground and the chassis is it's got to go through the bearings. So the bearings support the load of the vehicle, and they also are the link to ground. So in some cases, yes, if you've got an electrical problem, a short to ground, it's going to try and find it, and you'll see pitting and arcing on the raceways and the balls of a hub assembly. Now, you know, that's going to cause premature failure and noise, and unless you take the thing apart, you might not know what caused the failure if you're not sure of the ground. But yes, it is possible for it to be finding a path to ground through the balls and the tapers in the hub assembly.
Well,
and we see that a lot on the industrial side, Andrew.
Mm-hmm.
You know, we make a lot of bearings from NTN that are made for electric motors, for industrial use. And those do use insulation to prevent them from arcing, but because that will cause premature failure. And the same thing can apply to a vehicle, but in most cases, it's going to be a much lower voltage.
Yep.
I mean, we do see vehicles out there with like the 48-volt architecture. Mm-hmm. If that's going through the wheel, you got a bigger problem.
You got sparks.
Yeah, but if it's a car stereo, you know, some aftermarket, it's going to be a much lower voltage. Won't be as much of an issue, but you never want to have voltage running through places they shouldn't. So.
Yeah, there's going to be other electrical indicators letting you know that there's something wrong before you do an autopsy on a hub assembly.
And again, there is no over-the-air update for when you plugged in two 12-inch subwoofers in your trunk of your Chevy Bolt. And I know they're out there. I see them.
I hear them. Yeah. Yeah.
BMW will just charge you a subscription to it. So
there you go.
Well, we're at the end of today's event. I'd like to thank everybody for attending. Most of all, I'd like to thank BCA for sponsoring this event. So thank you, Patrick. Thank you, Matt. Anything you'd like to add?
Oh, we just want to thank everyone for sitting through the webinar. We will get back to you on your questions. Feel free to reach out to us, bcabearings.com. We've got a bunch of tech tips videos. All our webinars are there as well.
Yeah, and if you've got any comments or suggestions or odd things that you'd like to share that you've come across, send them our way. We'd love to hear about them and maybe include them in an upcoming presentation.
Yeah, thank you all.
Oh, thank you very much, and thank you, Patrick and Matt and BCA for this. Everybody, have a great day.